In some programs, a single level of decisions using if-else structures is just simply not enough. So in this video, we're going to explore how to combine if-else structures to make more complex decisions. Let's imagine we're writing a program to evaluate and play the game rock, paper, scissors. The way this game is played is two players each pick one of three options, either rock, paper, or scissors. Depending on which they pick, there's a winner and a loser. Rock beats scissors, scissors beats paper, and paper beats rock. So let's start by building some basic if-else structure. And we're going to want to evaluate first what player 1 has selected, and then second what player 2 has selected. So let's start with an if-else structure that checks the three different cases that player 1 could choose. So if player 1 chooses, let's say, rock, well, in this situation, player 1 is going to win if player 2 has chosen scissors, because we know rock beats scissors. So we can put inside this if statement another level of if statement if player 2 chooses scissors. Now, the line where my cursor currently is, that code is only ever going to be executed if both these if statements are true. And I know based on the game that if both these if statements are true, then player 1 wins. Now let's continue our logic within this outer if statement. So if player 1 has chosen rock, but instead player 2 chose paper, well, then player 2 wins. So I can add another else if structure within that outer if for that case. Paper. Now, only this line is going to be run if both player 1 chose rock and player 2 chose paper. Now, within that structure, again, there's a third possible option. If both player 1 and player 2 chose rock, well, then we have a tie. And since I know there's only three possible situations, then I'm just going to make this an else statement without a test. A tie. Let's run this code and just see what we've done. So we're going to choose rock for our player 1 because that's the only case we're currently handling. And then let's say for player 2, let's choose scissors. Yay, player 1 wins. Works correctly. And we'll try it one more time. Again, we'll choose rock, and this time let's choose rock again. And it's a tie. So now we are combining multiple levels of if structures. If we want to continue and finish this program, you can imagine having an else if down here that evaluates the other cases for the player 1, where this might be paper. And then you would have a third case, which again, we're going to leave as an else because we know there's only three possible cases. And here, I'm just going to leave a little comment to myself so I know what this represents. And this is going to represent player 1 equals scissors. Again, I don't need to test that explicitly because there's only three cases, and the else clause will catch if it's neither rock nor paper. Then I can copy this logic over again, but I can print out different things in each of these cases. So if player 1 chose paper and player 2 chose scissors, well, then player 1 loses. So player 2 wins because scissors beats paper. Whereas if player 1 gets paper and player 2 gets paper, well, then that's when we have our tie. And finally, in our else clause, this is going to be player 2 has then chosen rock. And in that case, paper beats rock, so player 1 wins. So as you can see, we can go on and continue to evaluate where we have an outer layer of evaluation and then an inner layer of evaluation. Now this can get a little wordy, so we can actually do exactly the same thing, but with the combination of ors and ands. So we can say if player 1, let's say player 1 chose rock. Now we also want to evaluate when they win, meaning player 2 has chosen scissors. So we want to, when that is true and player 2 has chosen scissors, I have to remember which one wins, then we can say player 1 wins. And we have done exactly the same thing as this, but in a more condensed form where we've combined things into a single if check. We could continue to go on and on. So for example, that's one case where player 1 wins. And I'm going to add a set of parentheses here just to make this really clear. And then, so that's one case where player 1 wins. But player 1 might also win when player 1, let's say this time they choose scissors. Well, if player 1 chooses scissors and player 2 then chooses paper, well, that's another case where player 1 wins. And then finally, the third case where player 1 wins would be paper. And if player 1 chooses paper, then player 2 chooses rock. Well, now I've got 3 individual Boolean expressions within a single if statement, and they are each connected by the double pike or operator. So essentially, the AND operator combines these two Booleans into a single Boolean, and it only evaluates to true when both are true. The OR operator evaluates multiple Boolean expressions when at least one of them is true. So the way the computer would evaluate this is it would first come and check this Boolean. If this is true, then it would check this Boolean. And if both of those are true, then it would pass this whole statement and jump in. But if this is, say, false, it'll jump all the way to here to check if this is true. And if that's false, it would jump all the way here to check if that is true, because it's just looking for its first true in order to continue to evaluate the AND operator. Not in particular are one of these preferred over the other method, other than you can see that we got very complicated within a single if statement here by combining so many Boolean expressions, which can make it a little hard to maintain. So sometimes it's best to use what's simplest to read as opposed to what is most compact. But if you find yourself having very elongated code, the occasional use of the AND and OR operators can help you really simplify things and maximize all of your decision-making abilities made available to you with the if-else operator.